Welcome back to sqadia.com, and as we are talking about the function of the wrist, it is very important to understand the bony framework and the joints that are involved at the level of the wrist and hand. So talking about the functions of the wrist and hand, because they serve as a single unit, we need to understand the bones that make up the wrist and hand and the joints which are at the level of the wrist and hand, including the joints of the wrist, joints of the fingers, and joints of the thumb. So in this figure, we can actually take a look at the different bones that make up the region of the wrist and hand. So here we have the distal aspect or the distal part of the radius and the ulna. Ulna does not directly articulate with the proximal carpal bones because of the presence of the articulating disc, whereas the radius articulates directly with the proximal carpal row, which is actually results in the formation of the radiocarpal joint. So here we can see the radiocarpal joint, and we have actually different carpal bones which are arranged in two different rows, and we can see that we have scaphoid, lunate, tracheatrium, and pisiform in the first row, and we have trapezium, trapezoid, capitate, and hamate in the second row. Once again, the first row and the second row of the carpal bones make another joint which is known as the midcarpal joint, and these two joints actually the radiocarpal joint and midcarpal joint, they come in combination, they form the wrist complex. On the other hand, we have 5 digits in the hand, and the first digit is also known as the thumb, and the second, third, fourth, and fifth digit are known as index finger, middle finger, ring finger, and little finger, respectively. In all of the digits, we have one metacarpal which articulates with the corresponding carpal bone and forms the carpal metacarpal joint, and that metacarpal then articulates with the proximal phalanx and makes the metacarpophalangeal joint. Now, there is one difference between the first digit or the thumb and the other fingers, that thumb has only two phalanges, so there is a proximal and a distal phalanx, whereas in the fingers we can see we have a proximal, middle, and distal phalanx. So there are three phalanges, and for that reason the thumb has only one interphalangeal joint, and whereas when we talk about the fingers, there are two interphalangeal joints, the proximal and distal interphalangeal joints. So as we already discussed, that the wrist complex has two major joints. One is the radiocarpal joint, which is this one, and one is the midcarpal joint. And talking about the wrist complex, it has 2 degrees of freedom because there are movements possible in two different planes. That is flexion and extension, and ulnar deviation and radial deviation, which is also referred to as the abduction and adduction at the level of the wrist. And because of having 2 degrees of freedom, this joint is also known as having or possibility of having circumduction as a possible movement. Now, when we talk about the joints of the wrist, as we already mentioned, we have the radiocarpal joint, which is this one, and we have the midcarpal joint, which is this one. Now, talking specifically about the radiocarpal joint, is a synovial joint and a condyloid joint in which the proximal row of the carpal bones actually makes a convex surface, and it is the distal articulating partner. And as it is convex, so the rule that it follows is convex and concave, so the roll and slide are opposite in direction in the wrist complex or the wrist joint. And as I already mentioned, the concave distal end of the radius, which serves as the stationary partner, and the convex proximal row of the carpal bones, which makes the moving convex part, and that is why convex and concave rule with rolling and sliding in the opposite directions. So as I already mentioned, is a biaxial joint allowing flexion, extension, and abduction direction, or ulnar and radial deviation, and has in short 2 degrees of freedom. Other than that, we have midcarpal joint, and it is actually between the two rows of the carpal bones, and it is very important in terms of its contribution in the wrist motion. And these are actually, their shape of those is irregular, and thus they are plane joints, and they are non-axial, but they allow gliding movements which actually collectively contribute to the radiocarpal joint motion, and we can say the excessive movements possible at the midcarpal joint or the intercarpal joints actually serves and contributes towards the overall movement of the wrist complex. So talking about the joints and motions of the thumb, so as we already mentioned, we have the carpometacarpal joint, first carpometacarpal joint as well, we can call that, and the metacarpophalangeal joint, and only one interphalangeal joint. So first digit thumb has three joints, as already mentioned: carpometacarpal, metacarpophalangeal, and interphalangeal. And the carpometacarpal joint is between the first metacarpal, which articulates with the trapezium bone of the carpal bones. Now, talking about the carpometacarpal joint, it is a very special joint because it is a saddle joint and it has 2 degrees of freedom. Uh, but it is special in the sense that each bony partner is concave in one orientation and convex in another orientation. So the saddle joint with both joint surfaces being concave and convex, and it allows flexion and extension as well as an abduction and adduction, and thus it is known as having 2 degrees of freedom. But it is also has another movement which does not actually can be categorized as an individual movement, but is actually a combination of flexion, extension, and abduction, adduction, respectively, and that is known as opposition and reposition. But if we consider opposition and reposition as an independent movement, we can say that it has 3 degrees of freedom, but that actually is a debate in terms of different textbooks. So, and normal position, we can say that the pad of the thumb is actually in the anatomical position is perpendicular to the palm, making a 90-degree angle. And when we oppose our thumb, the pad is facing or parallel to the palm. For example, this is my anatomical position. If I bring my thumb here, this is known as opposition and this is reposition. So we can obviously see that there has rotation occurred because the thumb was actually perpendicular to the palm and now it is parallel to it, so it means there has been rotation. So but if we individually want to try or perform the rotation ourselves voluntarily, that is not possible. So we can say that it is not actually an osteokinematic movement, but instead it is an arthrokinematic movement. So arthrokinematic movements are also known as excessive movements. So we can say that it is a modified biaxial joint because there are two true osteokinematic movements, which is flexion and extension, abduction and adduction. But once again, the opposition and reposition has a component of rotation, and that is actually an accessory movement. So that is not in the true sense osteokinematic degree of freedom. So that is why it is somewhere in between 2 degrees of freedom and 3 degrees of freedom. That is why we call it as a modified biaxial joint instead of a conventional biaxial joint. So here are the movements possible. So if this is flexion, extension, abduction, and adduction, and opposition is when I bring my thumb with my finger and I take it back, that is reposition. So this is flexion, extension, and this is abduction and adduction. Moving on, metacarpophalangeal joint and interphalangeal joint are not so as much mobile as the carpometacarpal joint of the thumb. And when we talk about the metacarpophalangeal joint, it is a hinge joint and it only allows flexion and extension, and it is a uniaxial joint as compared to the condylite metacarpophalangeal joints of the fingers, which are biaxial joints. So there is actually a very important difference. The carpometacarpal joint of the thumb is more mobile than the carpometacarpal joints of the fingers, whereas the metacarpophalangeal joint of the thumb is less mobile than the metacarpophalangeal joint of the fingers. The interphalangeal joint is a phalangeal joint and is the only phalangeal joint because there's only two phalanges, the proximal and distal phalanx, and there's no middle phalanx, and it allows only flexion and extension because it is a uniaxial joint. So when you talk about the fingers, they have the same carpometacarpal, metacarpophalangeal, proximal interphalangeal, and distal interphalangeal. The only difference is that there are two interphalangeal joints. Otherwise, they have the same interphalangeal joints, carpometacarpal and metacarpophalangeal joints. So second, third, fourth, and fifth digits, also known as index, middle, ring, and little finger, have 4 joints each, whereas in thumb we had 3 joints. So carpometacarpal joint, metacarpophalangeal joint, and proximal and distal interphalangeal joints, as I already mentioned. So when we talk about the carpometacarpal joints, in the thumb it was modified biaxial joint or a saddle joint, whereas in carpometacarpal joints of the fingers, they are actually non-axial plane and irregular joint, just like the midcarpal joints, and they are synovial joints and they provide more stability than the mobility. The fifth carpal metacarpal joint is actually comparatively more mobile as compared to the other carpal metacarpal joints, and thus there is a little bit of finger opposition movement possible, which we can see when the thumb does opposition. So there is a movement by the little finger as well. So this is the movement of opposition of the thumb and the finger. So it is not as much as the thumb. Whereas when we talk about the fourth metacarpal joint, it is slightly less mobile than the fifth, but more mobile than the second and third, which are actually pretty hypermobile. And when you talk about the metacarpophalangeal joint movement, it is initiated at the carpometacarpal. When you talk about the metacarpophalangeal joint movement, it is initiated at the carpometacarpal joints, and that is why they are important, because they provide that base of support for that movement. Now, on the other hand, we have discussed the carpal bones. We have talked about the joints between the carpals and the metacarpals in terms of fingers, which are the carpometacarpal joints, and they are plane joints. But other than that, between the metacarpals and carpals, we have the MP joint or the metacarpophalangeal joint, which are actually pretty much mobile, and they allow 2 degrees of freedom. Other than that, we have 1 degree of freedom in both proximal interphalangeal joint and distal interphalangeal joint. So metacarpophalangeal joints are biaxial condylite joints when we talk about the joints of the fingers, and they have rounded heads of metacarpals which articulate with the base of the proximal phalanges, which have a concave shape. And moreover, these joints, which are actually these joints which you can see here, these are the metacarpophalangeal joint, and these are also commonly known as the knuckles. The movements that are possible, as there are 2 degrees of freedom. So there is flexion, which is this is flexion, this is extension. I'm talking about the metacarpophalangeal joint of the fingers. So flexion, extension, and if we look at this way, so this is abduction and this is adduction. Abduction is away from the middle finger, and adduction is towards the middle finger. So motions allowed, as already mentioned, flexion, extension, and hyperextension, and abduction, adduction as well. And as already mentioned, middle finger is the point of reference for abduction and adduction. And there are 2 interphalangeal joints in each finger. And those interphalangeal joints are actually uniaxial hinge joints and allow only flexion and extension. For example, this is the movement of the distal interphalangeal joint, and this is the flexion and extension of the distal interphalangeal joint, and that is the only movement possible at the interphalangeal joints. So that was all about the joints and the bony framework of the wrist and hand and its significance. We will study in terms of the functions of the hand in the upcoming sections, and I hope you learned something new out of it. So keep on watching sqadia.com for more lectures like this. Thank you very much.